So for this question, we have light from a helium neon laser and it has 633 nanometers wavelength. So let me just draw it. From a helium neon laser and it has wavelength 633 nanometers. And it's incident on a slit, a single slit, and it has a slit width of 2.0 times 10 to the power minus 4 meters. It results in a diffraction pattern. I'm just going to draw the diffraction pattern, the intensity pattern. And it's formed on a screen, and the screen is actually 2 meters away. So I'm going to just write it down here. This is 2 meters away. The question asks me to find the width of the central maximum, and it defines it to be the distance between the dark fringes on either side of the central maximum. So if I were to put this on the diagram, this would be the width. So before I jump in to do the question, the first thing I want to do is analyze this particular question and think of how we can actually do it. So what we can do is we see that if we are able to find this theta, the angular displacement of the first minimum, then we will be able to determine this value of y, and we will know that tangent theta is equals to y over L, and hence from there we can determine the value of y, and y itself is related to the width, where width is actually equals to 2y. So my first task is actually to look for theta, and then to determine y, and then finally I can determine my width. So how do we get theta? So to get theta, we simply use our single slit equation where we have b sine theta equals to n lambda. But we know that this is the first order minimum, so n is equals to 1. So we have b sine theta equals to lambda. So what we have is sine theta is therefore equals to lambda over b. So we can put in our values of lambda and b, and we will have 633 times 10 to the power of minus 9 over 2.0 times 10 to the power of minus 4 from the question. Now, if you look at this particular value, you will see that 633 times 10 to the power minus 9, that is about 10 to the power of 2 times 10 to the power minus 9, and that will give me about 10 to the power minus 7, and it's divided by a number of 10 to the power minus 4. That typically gives me a value that is about 10 to the power of minus 7 over 10 to the power minus 4 is about 10 to the power of minus 3, and that is actually a very, very small number. I'm going to work this out. This is equals to 0.003165. Now, if we apply small angle approximation here, then sine theta is approximately theta, is approximately tangent theta when it is in radians. Then we can actually approximate this equation by theta equals to lambda over b. And with that, that gives me 0.003165 radians. Earlier on, remember what we want to do? We want to find theta. So we've determined theta itself, and then what we can do is determine y. So from this equation, y is equals to L times tangent theta. But using small angle approximation, when theta is very small, tangent theta is approximately theta. So this is actually equals to L times theta. So putting that in, we'll have 2.0 times 0.003165. And that will work out to be equals to 0.00633 meters. With that, we can easily find now our width, because our width is actually 2 times of y. So width W is 2y, and that gives me 0.00633 meters times 2, and then converting it into millimeters, you will get 12.7 millimeter.